time there's been quite a strong relationship between disease and treatment, and if both of you and I have the flu, we're usually given the same medicine. If both you and I have a certain disease, we're usually given the same treatment. But we've lived through an era, luckily, of technology coming into everything, and one of those things is hospitals. And one of the byproducts of adapting technology was the storage of huge aggregated private data sets. And we have had kind of a little bit of a discovery, which is that because of this data that we have now, we realize that it's not a one-size-fits-all approach when it comes to treatment. So the NHS actually defines personalized medicine as, and I quote, a move away from a one-size-fits-all approach to the treatment and care of patients. And it makes sense. I mean, in the NHS today, you see many applications of personalized medicine. I believe we mentioned earlier Google DeepMind, who are partnering with the NHS to bring AI into the world of diagnoses and treatment. IBM Watson is doing the same thing in the University of Texas. So, and how does it do that? Well, there's 2.5 million research papers published, a lot of which are medical papers every year. And obviously no human or group of humans can easily read that in such a short amount of time, whereas a computer can, right? Correlations between patients are much easier to find, and diagnoses and treatments. And that's basically what these machines do. It reads a lot of data and identifies patterns and then learns from it. And using that and previous diagnoses, it can then predict or suggest treatments that may have worked, or treatments that may have not been trialed yet, or are not been tested yet on patients but have already been trialed. So I'm personally looking, as I said, into AI, using AI for medication schedules. And the reason I do that is because I had to undergo surgery myself, and the way medication is prescribed is quite standard, right? So they go paracetamol every 4 to 6 hours, ibuprofen every 6 hours, 6 to 8 hours, and morphine you would have to take, for example. I was on morphine, it's a hell of a drug. And I had to take that also on a very, very standard routine, but that meant that I couldn't really tailor what time I took my meds, because there was a point where I had to take all three at the same time. So I'd be knocked out for a good 3, 4, 5 hours. I was sleeping 16 hours a day. And I realized that, well, instead of giving 500 milligrams a 500 milligram pill and telling someone you should take 2 of that every 4 hours, we could personalize that. We know the limits of the drug should be, for example, 4,000 milligrams in the bloodstream. So let's make an assumption that, a patient takes an antibiotic 4 times a day, right? Antibiotics are a bit different, so I'm going to switch that to painkillers actually. They have to take a painkiller 4 times a day, and one of the requirements of this painkiller is to take it with a meal, right? Ibuprofen is a great example. So that means that that patient has to plan what time they eat if they want to take the medicine as well, right? So if I have to eat every 6 hours, that means if I have my breakfast at 7, I can't have my medication until it's 1 o'clock. Did I calculate? Yes. So we can also do it the other way. So instead of planning meals, we could say if we want to go do our groceries at 5 p.m., what time should I take my painkillers to feel the most relief? And that's kind of what I'm doing at the moment. And it's really interesting to see that, because it's about bringing an individual's characterization into the treatment, something that's not really been done before. And although it's quite new, it's being used those approaches are being used at the moment in very specific fields like cancer. You see that in cancer we use the genetic base to help select the most effective treatment, which is proven to greatly improve survival chances. And so why is personalized medicine important? Well, we use these techniques to identify people at risk of disease, which means we can prevent these diseases from the start and give people kind of indications of what kind of lifestyles they should be living and make better life choices. But also, today we're using tests to come up with diagnoses when we have two patients that have the same symptom, the cause of these symptoms could be completely different in 2 patients. So the knowledge of each person's lifestyle comes into the loop, and it enables us to fully understand the issue and address it correctly. And finally, the way it works at the moment is when you go to your GP to ask for medicine, what he'll usually do is he'll say, okay, try this, and if it doesn't work, come back to me. And then he gives you the second round. He goes, okay, try this, and if it doesn't work, come back to me. And it's a trial and error sort of process, and it's not very helpful, and it's also quite harmful to the body, because you're exposing it to a lot of different drugs. And if you can improve that, you improve healthcare, and then as a result of that, it'll have an indirect impact on the UK economy. Obviously, there are startups appearing right, left, and centre tackling these sorts of things. I was actually building an app before I started this company that was basically that concept of personalising medication schedules. A friend of mine who's actually a GP, she's fantastic. she decided to build an app that is called a cancer calculator to determine exactly what treatment plan you should get if you're ever diagnosed with cancer, because everyone has different lifestyles and different attributes.